So, in the previous session we have seen how the density of the liquid changes with variation with temperature, and we have seen that if in a vessel the pressure at the bottom will also change, that will depend on the area of cross section of the vessel also. So, now let us see the effect of temperature on the measurement of barometric pressure. So, barometer is an instrument used to measure atmospheric pressure, and we take a mercury in a vessel, this is mercury, and we take a 1 meter long tube completely filled with mercury. So, this is suppose a 1 meter long tube, we have filled this with mercury and we will close that end and then we will invert it and dip it and then we will open it. So, what we find that this is the tube which was completely filled with mercury. So, mercury has this type of meniscus. So, when the tube is just brought to the surface, so that this mercury and this mercury is in contact, we find that the mercury level here falls down from this, and so there is nothing left out here, we say it is vacuum. So, this height h naught corresponds to the atmospheric pressure. You can see, you can apply from this point and this point, that is the pressure at these 2 points can be equated. This is atmospheric pressure P atmospheric, and the pressure at this is H naught rho naught for mercury into G. So, this H naught is the measure of atmospheric pressure. So, atmospheric pressure here is 76 mm of Hg. So, that means if it is 1 meter, then 760 mm of Hg, that means 76 centimeter will this height, this is 100 minus 76. So, this distance the mercury falls. So, this column of mercury is going to support the atmospheric pressure. So, this is how a barometer works. Now, what will happen when we change the temperature? Suppose this is the reading at 0 degree centigrade. At 0 degree centigrade the reading was H naught. So, at theta degree centigrade this density of the mercury changes, the atmospheric pressure remains the constant. So, H will be different. So, the new height will be different. Let us see what will be the new height of the mercury, that is new height means new barometric reading. So, now let us see that we will assume that the vessel, this tube does not expands. So, let the barometric reading be H naught at 0 degree centigrade, which is, so H naught is at 0 degree centigrade. So, density, so at theta degree centigrade the barometric reading is H. So, let H be the barometric reading. So, we will calculate what will be the H. So, the volume of mercury or the atmospheric pressure does not change. So, we will assume that the atmospheric pressure initially was H naught rho naught G. Now, new atmospheric pressure is again the actually atmospheric pressure does not change, but new reading will be H. Density becomes rho naught 1 plus gamma mercury into theta into G. So, by comparing these two, we will have H naught rho naught G is equal to H rho naught G by 1 plus gamma mercury into theta. So, this is H, this rho naught G cancel. So, H becomes H naught 1 plus gamma mercury into theta, where theta is the. So, the new height of the new mercury, the new reading of this barometer at theta degree centigrade will be increased to 1 plus gamma m theta times. So, this is the barometric reading at new temperature. Now the point is that this reading is measured by must be measured by a scale which does not change, but it can't happen. So suppose I have a brass scale attached here. So I have a brass scale. This is a brass scale attached here, and this brass scale is designed to read correctly at 0 degree centigrade. So let there be a brass scale which reads correctly at 0 degree centigrade. That means at 0 degree centigrade H naught is the correct pressure. Now I want to know that at theta degree centigrade what will be the barometric reading if I see the reading in brass scale. Here this is the actual reading. So let us see what it will be in a brass scale. So with rise in temperature, the brass scale will also expand, and so then it will become a faulty scale. We will use that expression that true scale reading is equal to 1 plus alpha theta times faulty scale reading. So we are, what is the actual height at theta degree centigrade after the expansion of mercury is actually, that is H naught 1 plus gamma m into theta. This is this term, and this is 1 plus alpha brass theta times faulty scale reading, that is brass scale reading. So brass scale reading at theta degree centigrade is given by how much? H naught times 1 plus gamma mercury into theta by 1 plus gamma brass in alpha brass by theta, that is H naught 1 plus, on simplification and taking the binomial approximations, gamma mercury into alpha brass times theta. So this is the new reading of this new pressure. So this is the reading of the barometer with a brass scale at theta degree centigrade. So the reading is at 0 degree centigrade, it has H naught. At theta degree centigrade with brass scale, the reading becomes H naught time 1 plus gamma m alpha brass